Well, thank you all for being here, and thank you, SE, for giving me the opportunity to present on Bleu Ciel today. It's a project that's been keeping me busy for a good part of the last 2 years. So let me first give you a little word of introduction about LFE's partners, in case some of you don't know us. We're a structural-only engineering firm. We're based in Dallas. We're founded in 1979 by Larry Fuess. Currently, we have slightly over 70 engineers. We also have an office in Boston. Some of our most notable projects are the Legacy West project right now going on at 121 in the Tollway. Liberty Mutual is also going up there. We have the Toyota North American headquarters that you probably have heard of, the DFW renovation, and in Fort Worth we also have the Frost Tower. Now I'm going to talk a little bit about the background regarding Bleu Ciel. Bleu Ciel is developed by Harwood International. Harwood International was founded in 1988 by Gabriel Barbier-Muller. He's a Swiss-born citizen who came in Dallas and started with his first building, was a products building in 1988. Harwood International also has properties in Paris, Zurich, Geneva, London, but the masterpiece is the 18-city block known as Harwood in Uptown. They are best known for transforming this neighborhood from pretty much nothing in 1988 to a vibrant office community now. So here's the aerial view of the Harwood district. That little red box up there is the Bleu Ciel project. You can see it's nestled between the Victory Park development, Uptown to the east, downtown to the south. You can see I-35 going north-northwest and the tollway going north. This is a prime location for office buildings. Like I said earlier, this is an 18-city district. They have commercial properties, residential properties, hospitality, restaurants, and they have a very important place left for the arts. Gabriel Barbier-Muller is a samurai art collection, and throughout the district, every one of the developments has samurai art showcased at the lobby. Harwood is also expecting to continue to grow and develop fully the district to include over $3 billion of additional development in this area. They're keeping really busy right now, and one of their other projects that we're working on is this 8th development, the Rolex building. This building was designed by Kengo Kuma of Japan. He's a very famous architect designing some of the stadium for the next World Cup. The architect of record is HDF. It's Harwood's own architectural firm. The landscape design was done by Sadafumi Uchiyama, who is the curator of the Japanese Garden in Portland. And this building just stopped out last December. We're still working on it. It's taking a little while, as you can imagine, to install the glass on this building. The interesting thing about this building is that every floor plate is rotated from the previous one, so it will be large terraces that will be landscaped at every floor. Also going on at the same time is Harwood number 10. This one was designed completely by Harwood's own in-house architect, HDF. It will be 22 floors, 226,000 square feet. It is the 10th development. This one just started construction. They're drilling piers and pouring grade beams right now. The ground level will have 14,000 square feet of retail and restaurant space that they are lining up against an existing building to create an alleyway, kind of like something you would see in Europe. Now let's jump on to Bleu Ciel. Bleu Ciel was designed by Jean-Michel Wilmot of Wilmot et Associés in Paris. The record architect on the project is HDF. The landscape design was also by Sadafumi Uchiyama. Structural, obviously, is by LFE's partners. The MEP services was sets mechanical engineering, mechanical, electrical, and plumbing. That was Bleu Consulting Engineers. Civil engineering was provided by Half Associates, and on this project we also had a wind tunnel consultant called CPP. The construction team on this project is Hunt Construction, who is a general contractor. The construction management was provided by HTMS, which is Harwood's own in-house construction management. The concrete was delivered by Capform, and the structural steel was provided by Red Steel. There are many more contractors, including the temporary retention contractor, but I'm just going to talk here about the ones that we actually dealt with a lot. The project is 33 stories tall, that's 390 feet above ground, but there's an additional 52 feet below ground. That's 570,000 square feet above ground and 202,000 square feet below ground. So if you consider that you have 32 stories above ground and 5 stories below ground, you can see that the basement is significantly larger than the tower footprint. So let's start with what's under the tower. This is a geological map of Dallas, and the blue arrow is pointing to where the project is. In this area, as some of you may know, whether you're on one side of the highway or the other, it makes a tremendous amount of difference. In this case, we're in the Austin Chalk Formation. The Austin Chalk Formation is basically a few feet of clay, and then in this case we have about 70 feet of limestone, and below that is shale. Now the reason it's relevant is that our foundation starts 52 feet below ground, but we also have the elevator pit, and because it's a tall building, the elevator pit is pretty deep. So the lowest foundation starts about 64 feet below ground. So at that point, we've pretty much exhausted all of the good limestone. So what we had to do is get in touch with the geotechnical engineer to figure out how to adjust the values to take into account both the limestone and the shell that we would be penetrating with those spears. So I'm proposing to go up the building to look at the design, and we're going to start with the lateral resisting system. This concrete shear wall core that you see here is basically what's keeping the building in place. This is, I believe, about 52 foot long and 30 some odd foot wide concrete shear wall core. So to design it, we basically created a preliminary model, and we sent that information to a wind tunnel consultant, and we told them basically here's the stiffness of the building, and with that they create a model, and we also sent them a 3D model of the building so they could create the skin of the building around it. So they create that little scale model of the tower, and they drill little holes all over the facade to put pressure tabs on the building. I believe there's more than 300 pressure tabs on the model that will be measuring data points of pressure. So here's a view of basically the table on which they mount the building. You can see the building is a clear building on this picture, but they also build all the surrounding buildings in the area to get a good idea of how the wind flow is affected by the built environment around it. That table represents 1,600, it's a 1,600 foot radius basically around the tower. You can also see those little boxes in the tunnel. These are just to create some turbulence in the flow to kind of represent the city around. Another piece of data they need is the wind speed analysis for the area. So I'm saying here Dallas Love Field, it's actually from the Dallas Fort Worth Airport, but this shows you the wind speed direction and probability in the region. Here it's mostly a southerly wind, and so they use that data, they fire up the fans, measure the pressure, and they turn the table on which the tower is placed to get basically pressure values depending on the wind direction. So now let's talk about the basement a little bit. So like I said, this basement is very, very large. It is so large that most residents will have a 2 to 4 car garage. Here is a picture of the basement excavation. It's kind of hard to say, the picture doesn't do it justice, but it's extremely deep and extremely long. You see that tower in the back, it's Frost Tower. You could actually take that tower, turn it on its side and feed it into that excavation. The basement system. So like I mentioned earlier, we had a temporary retention system because the excavation was so deep and we were right next to the entrance to the tollway, so the slope cut was not an option. So it had to be a temporary retention system. So what the contractor does, they excavate 5 feet of dirt, put soil nails, excavate another 5 feet, put soil nails on a regular spacing, and they keep going like that. On top of that, they will shotcrete the face so that the contractor has a flat surface to work on. The next layer is basically a drainage mat that will gather all the water infiltration at the top and direct it to the bottom. We then place a waterproofing membrane to basically prevent water infiltration inside through the concrete inside the basement, and then of course we pour the basement walls. So this is what it looks like at the base of the basement. The water is being gathered inside the drainage mat. It gets to the bottom. We have sleeves at regular intervals all around the perimeter to basically move the water from the back of the wall to the perimeter drain system that is under the slab at the base. So let's move up to the ground floor. So the ground floor is just packed with amenities for the residents. There is a juice bar, there is a bike shop, there is a gourmet grocery market that will be bringing the groceries directly to the residents' units. There is a 24/7 concierge service and a valet parking for the residents at the front entrance. This is the main lobby. It actually goes higher than that. It's 30 foot tall. There's a water feature inside the building. That glass has no structural support. It's structural glass. It's designed to spine by itself 30 feet. It's basically a floor plan of the ground floor where you can see the valley drop-off area. The main lobby is to the west here. And as you go towards the east, you have to the northeast corner, you have a grocery store, and then you have other retail areas to the south. On the space that is not right under the tower, but the continuation of the basement, it will be basically a huge plaza with up to 6 feet of dirt on top. It will be fully landscaped. There will be another water feature, and it's also designed for possible future retail on top of it, probably a restaurant. But now there's also another aspect to this ground floor that is not quite as fun as all those amenities. This tower, 390 feet, is basically cantilevering off from this floor. So all that wind load that is accumulated in the tower gets down at this level to be redistributed into the basement walls. This is called the backstay effect. This is a tremendous amount of load that's trying to get to that ground floor slab. The ground floor slab is 18 inches thick in order to be able to take that load and redistribute it to the basement wall. Let's keep going up. So now we are going inside the retail parking. So as the name indicates, this is for the retail tenant now. One interesting feature of this retail parking is this stair that basically wraps and weaves around the building. So we had to cantilever our parking slab past the face of the building to go pick up that stair. And you can also see that the last run actually pierces through the 6th floor pool deck. Another thing that's happening at this retail parking is that we have an interesting alignment situation here where when we study on this project, the unit layout was already pretty much decided. So this column here in blue is lining up with where the walls are in the residential units. But unfortunately, that column also falls right inside the retail ramp to the parking garage. So we had to somehow transfer that column down to 2 adjacent columns. The load coming down this column is 6,900 kilopounds. So after a few preliminary calculations, we figured that our transfer girder was pretty much going to be a transfer wall. That's a 4 foot thick by 17 foot tall transfer wall. Problem with a 4 foot thick by 17 foot tall transfer wall is that it does not really behave as a beam anymore. It's a beam, it doesn't bend, it's just pure shear, and so we have to use special techniques called strut and tie modeling to come up with a design like that. As you can see, it's a little bit congested. There's a lot of steel in there. The next floor up is the level 6 podium. So this podium is the first level where we actually have residential units. You can see to the west side here, there's 2 units called garden homes. The reason they're called garden homes is because the terrace is recessed 18 inches so that homeowners can actually go out and plant on those terraces. So there will be gardens on those terraces. For all the residents, you also have a fitness center. You have a spa that is exclusively for the residents, and you have a pool deck. The pool deck is basically, it's a pretty nice pool deck. You have a hot tub. You have 2 junior Olympic swimming pools. So that first one is actually probably not a swimming pool, it's only a few feet deep, but it has those palm trees in it, lounge chairs, and it spills over an infinity edge into that other swimming pool. There are cabanas all around the swimming pool on dirt. And it's a very nice feature for the residents. Moving on to the next floor, which is basically the typical floor. Here is a typical unit layout with most important in that picture is actually the size of the terrace. From the get-go, the developer's goal was to have the largest terrace in the United States. And they did it. You can see up there, it's a ping pong table. And I would not advise playing ping pong. I mean, the smash volley, it's gone. But anyway, this is a 15-foot cantilever from the column to the edge of the balcony. The reason that's relevant is that we have a two-way post-tension flat plate system. The way this is supposed to work is you have uniform post-tensioning tendons in one direction and bending tendon in the other direction. And what that does is basically allows us to keep the slab very thin. It's a flat formwork. The mechanical can just run unobstructed. There's no beams. It's a very efficient system. But in our case, we had to go pick up those corners somehow. So at those corners, the post-tensioning is really running in 3 directions. So you can see the bended tendons here. That's where you have the big congestion going basically transversely diagonal. We are going uniform in 2 directions, and we are going bended in 2 directions. To make it worse, this is actually also where terrace is happening, so the slab steps. So every elevation of this tendon had to be figured out before in order to avoid flashes in the field. It was quite a tricky situation. I'll stay here for a minute. The typical floor is repeated 23 times. On the construction side, they actually put one of these floors every 5 days, so it's a pretty fast space. The reason they can do that is because of the repetition, of course, and like I said, the flat plate is a very efficient system. They can just move the forms out and put them back to the next floor and start again, so it goes extremely fast. They don't have to actually form everything every floor, so it's just a repetition, and it's extremely quick. So that floor is repeating 26 times, something like that, and then you get to the penthouse floors. Penthouse floors have pretty nice views. This is a picture I took about 2 weeks ago when they were pouring the last floor. You can see downtown here. This is looking south from the tower. The penthouse floors are packed with amenities for the lucky owners. It's basically a 2-floor system. They have elevators taking them from the 32nd to the 33rd floor. They have an entertainment area on the 33rd floor, which is also the roof. This will also be landscaped by Sadafumi Yoshiyama, the curator of the Japanese garden. And it will not be complete without a pool. In this case, they actually had two pools, one for each unit. To make it a little bit more interesting, they decided to cantilever those pools at the edge of the building. This is 32 floors of nothing below those pools, and it would be nice if it was just a pool, but it would be better if it was glass. So there's glass in the front, glass below. There's also glass in the back. You can see it in this picture over the living room below. In the back of this pool, there is actually glass as well. So here's a cross section to that pool. You can see the glass here in the front. It's basically an L-shaped piece of acrylic panel. There is glass in the back over the living room. That glass is 6 inches thick. I don't know if that makes you any more comfortable. For having walked the deck last week, I can tell you it will take some pretty courageous individuals to go take laps in that pool. There's a gunite shell that is spread over our structure. And you can see the structure is pretty beefy, but it's still very scary. There's a cross-section going the other direction. Same thing, you can see the glass, the acrylic panel here. There will be, of course, handrails on the side to prevent fall. And around those penthouses, we also have the crown, what is called the crown of the building. So this is basically a screen that varies in height from 10 to 25 feet. The wind pressure on that screen goes up to 75 pounds a square foot. So we provide this tube steel frame basically that goes and wraps around the skin of the building and braces back to the columns and shear walls to provide stability to that screen. It also provides shade. I mean, it screens the owner from the wind up there, and will also provide shade because they will use those outriggers to put shade structures on the sides here. You can also see here this big tall box is where the cooling towers for the whole building will be placed. There's 3 cooling towers. Each one weighs 90,000 pounds. This 25-foot tall screen wall. It also needs some backup steel there. And there's additional mechanical going into the space above. Those are the roofed areas, which are the party spaces for the homeowners. Here's the real construction update. So this building just stopped out last week on Tuesday. Like I said, they were pouring a floor a week, so it went really fast once they started hitting the typical floors. I think they're still working on the glazing. I believe the first tenants are expected in July of this year, but they will keep building the interiors at least for another few months until they can finish this stuff. All right. Do you guys have any questions?